Hi everyone, today I'm going to talk about basics of logarithm functions. So how to convert log to an exponential function. Log to the base of 15 and then the power would be 2 equals 225. The second example is how to convert exponential to logarithm to logarithm form. So we have 3, which would be the base of log, 180, the 100 over 81 would be the value, and then equals to -4. Now, how to find the value of the logarithm function? So if they gave us any logarithm function, we would put equals to y, and then we would convert it to an exponential function, which would be 2 to the power of y equals 64. And then we would find the number that gives us 2 to the power of any number that gives us 64, which is 2 to the power of 6, which gives us 64. So y would be 64. Y would be 6. Now log to the base of 5, 625. We want to know what does it equals. So we would put 5 to the power of y equals 625, and then we would find the number that 5 to the power of a number that gives us 625. I think it is 4. So y equals 4. And if you will put this in your calculator, 5 to the power of 4, which would give you 625. So the value of a guitar in dollar after X years can be multiplied by the equation. So we have this equation where G is the initial cost of guitar and the initial cost is 400. Write an equation to find number of years it takes for a guitar to reach a certain value. So we want the equation to equal to X. So the equation is Y equal G 1.0065X. And they gave us G as 400, so we would replace G with 400. So what we're going to do first is divide by 400 to get to leave this term by its own. So 1.0065x, to the power of x. So this is to the power of x. To leave x by its own, I'm going to insert log 1.0065, which would cancel this. And then I need to do the same for the opposite side, which is log 1.065, this is 0, y to the power of 400. And this is the answer. So I just insert log 1.0065, which is the base. This is the base of the log. It's when you see log by its own, it means that it's the base. It's base of 10. Because you have different types of log. And here I used log to the base of 1.0065 because I wanted to cancel this term. Because log base of 1 and 1 would give us 1. Just let me check. Also, it would. Yeah. So let's say base of 10 and 10 would give us 1. Let's say base of 14 and we have 14 in here, it will give us 1. That's the reason I used base of 1.0065 because I have this number 1.0065 to cancel it out and to give me 1 and to give me x by its own. So yeah. So a logarithm graph, how to graph it? A logarithm graph looks something like this, which is log to the base of b, x. b in this case 1 over 9. And we have an x-intercept, which is 1 and 0. And in the logarithm function, we have 3 points that you need to know, which is 1 and 0, which is the x-intercept, b and 1, and 1 over b, -1. Those are the 3 points that you need to know. So let's draw this function, which the b in this case is 1 over 9. So let's try the 3 points that I just said. B and 1, which is 1 over 9, B in this case, and 1, B is this. And then 9 and -1 because we have a point that says 1 over B and -1, and 1 and 0, which is always there, 1 and 0, which is the x-intercept in the logarithm graph. So let's write the coordinates. 1 and 0, then 1 and somewhere in here, -9 and 9 and -1. And if we draw this graph, it will never intersect with the x-intercept. It will never intersect with the y-axis. The reason is it's a second asymptote. So it would look something like this. And we have an imaginary asymptote in here as well as an imaginary asymptote in here. How to graph this logarithm function? So we said that the 3 points that we have, 1 over 1 and 0, b, which is in this case is 2 and 1, and 1 over b, which is in this case 1 over 2 negative 1. So this is our coordinate. We know that the points are 1 and 0, just slightly somewhere in here, 2 and 1, which is somewhere in here. And then we have 1 over 2 and -1, which is somewhere. So the graph would look something like this. It's the opposite of that graph because that graph b was smaller than x, so it was kind of a reflection. In this case, b is bigger than 0, so it looks like this. So if b was smaller than 0, it would look something like this. But it can't intersect with the x-axis, don't forget. Sorry, the y-axis. So how to solve for x in this example? We have log base of 4x equals to 3 over 2. We will convert this to an exponential function, which would be 3 over 2 equal x. Putting this in your calculator, which would give you 8 for x. So x equals 8. Easy as this. So how to solve for x in this case? We would cancel log 4 and log 4 as they are equal on both sides, and we would be left by 2x to the power of 2 minus 4 equal to x, with minus 2x, which would give us this, and then x would give us 2 answers. Using the quadratic formula, you will get those 2 answers. In this case, we would cancel log 5 and log 5 in both sides, which would be left with x squared minus 6 equal x. We would minus x, which would give us 2 answers for x, which you can find using the quadratic formula. So there are initially 1,000 bacteria in a culture. The number of bacteria doubles each hour. The number of bacteria n present after t hour is given. So we have a function here. How long will it take the culture to increase to 50,000 bacteria? So we know that number of bacteria is n, so we would replace this with n. So 5 equals 1, 2. We want to find t, which is the time. We would divide by 1,000 both sides, so this would cancel, leaving us with 50 equals 2 t. We will get log to the base 2, so we can cancel 2, which would give us 1, log to the base 2. So the answer would be log to the base 2, 5 equals t, which if you put in your calculator, 5 would give you 2 2.3. So the answer is 2.3. So let's solve for p, which we know log. If we convert the exponential form to a logarithm form, which will be log to the base of 8, p equals p. How you solve it? And then if you have a calculator in your test, you can find this. So then log in here, which is base of 7, 15 equal 1. So to solve this, we would convert it to a logarithm form, log 5, 120, for x minus 2. There's no use of this, so that's how you do this. So I would use log base of 5 to get rid of this, log base of 5, and log base of 5 120, which would give me 2.97. So 4x minus 2 equal 2.97 plus 2 plus 2, and then divide by 4 to find x. So which would give me 3, approximately. So how to solve for x in this example? We will do log to the base of 7, which would give us 1 in this case, and we will do the same in here, log to the base of 7. So which would give us 3x minus 1 greater than or equal to log base of 7, 21. And then we can add 1 plus 1, and then divide by 3, which would give us x is greater than or equal to this. And if you would put this in your calculator, just give me a minute. It would give you x is greater than or equal to 0.85. So those two log functions can even equal log to the base of 10, so we won't write 10 in here. 22 divided by log to the base of 10, we won't write 10, 4. And it's the same in this case, log 200 divided by log 12, which is exactly the same as, this form. And let's see if they gave us, let me erase this. Let's say if they gave us log, let's say 30 to the times 34. This equals log 3 plus log 3, 4.